Hello, sir. Am I audible?
Yes, ma'am.
Okay, ma'am.
को दे के जाता हूँ
Hello.
दैट
Yes, sir. Good evening, sir.
Hi, good evening. Can you hear
Sir,
me?
can we wait for like 2 or 3 minutes before starting the session?
Sure, we'll do that.
Thank you, sir.
Mute कर दो. So, you have given the slides to them, no? Yes. See if you can give the edit. Okay. I've already sent this. ठीक है.
Sir, can we start now?
Yeah, hi. We can
Hi,
start.
sir. Okay. Good evening, all. Welcome to day 2 of ATAL Online Faculty Development Program. Today, for the first session, it is my honor to introduce Architect Hiten Sethi, sir, CEO and founder of Hiten Sethi and Associates, a leading architectural firm with over 3 decades of expertise in sustainable urban design. His notable projects include the National Cancer Institute in Nagpur, the Navi Mumbai Municipal Corporation headquarters, and the National Institute of Securities Markets, all of which embody innovation and environmental responsibility, with many receiving gold and platinum green certifications. Architect Hiten Sethi sir has also contributed significantly to policy and professional bodies, serving on the State Expert Appraisal Committee under the Ministry of Environment and Forests, and currently chairing the Navi Mumbai chapters of the Indian Green Building Council and the Indian Plumbing Association. Recognized with prestigious national and international awards, he now leads the ambitious Naina project in Mumbai, shaping the future of sustainable urban living. I welcome you, sir, to deliver the session. Sir, over to you.
Hi, good evening, all. Uh, First of all, I think it will be my first time I'll be speaking for 1.5 hours. So excuse me if I get boring a little bit, but I like to keep it crisp for all of you to enjoy the subject. Can you see the screen?
Yes, sir.
Okay. Uh, so, hi friends. Today we gather not merely to discuss sustainability or challenges in the developing cities, but to confront a profound responsibility we share as stewards of our environment, our community, and communities for our future. Sustainability is no longer a choice, it's the lens through which we must view every decision, every design, and every ambition. It's about balance between progress and preservation, invoking an integrity, whether we are architects shaping skylines, engineers, or policymakers drafting frameworks, or citizens making daily choices. Our action ripple outward, impacting ecosystems, economies, and generations yet to come. This lecture invites us to rethink what it means to build, to consume, and to thrive. Let's explore how sustainability can be more than a technical goal. It can be a philosophy of care, resilience, and regeneration for a better future. That's right. So, no, climate change is not a thing of future. It's a concern of today for the future. Next slide. So, where we are standing, we are all architects attached to building fraternity, all attached to somewhere or the other, attached to the kind of construction which we are seeing. All of us are living in the golden era of construction. So many of developments happening. I mean, my generation, we have seen so much of diverse technology advancements that one can even wouldn't have imagined 30 years back. You guys at your age, you are sort of lucky enough to apprise all these particular things from the time of you open your eyes and move towards a better future and successful future. However, we have to understand where we stand, because every development what happens uh, and has a price to pay. So let's understand that the built environment sector is responsible for more than a third of global energy related carbon emissions. Now, the residential, what you see, it has impact of 17%. It has direct impact, it has 11% indirect impacts. Now, you have non-residential sectors in which you have commercials, you have so many other things, TODs, industries, which have a total impact of 3% as a direct and 8% as indirect. We have building construction industry in which all the concrete, aluminum, steel, everything is developed, which has impact only mere 6% compared to other sectors which I'm discussing about. And estimated emissions for bricks and glass turns out to be 3%, which has been going on from years to come. And as the technology is growing, 3% keeps on getting more evolved in terms of secured as well as advanced kind of technologies which impact carbon emissions. Now, what do you mean by direct influences? Direct influences are on-site emissions. These are emissions that occur within the residential property itself, mainly from fuel combustion or processes happening inside the home. For example, natural gas for cooking or heating, using kerosene or coal for heating or cooking, on-site DG sets for power backups, wooden burning stoves or fireplaces which add to biomass combustion, leakages of refrigerants from air conditions or refrigerators, HVC gases. These are the kind of things which influence a built environment as a direct influence towards residential or non-residential sectors. Now, what are indirect influences? These are off-site, or you can call it upstream emissions. These emissions occur outside the home, but are linked to products or services consumed in the residential sector or either non-residential sectors also. They're the part of supply chain or energy generation processes. For example, we consume energy, we consume electricity. These are the emissions are created at the power plant if it's coal-based or gas-based. manufacturing and transportation of building materials itself adds to these kind of indirect things. Like you have to carry your cement from the cement plant, you have to carry your steel from the cement plant, you have to get your tiles from the manufacturing place, you have to get the paints to your sites. Water supply and treatment. There is lots of energy which is used to get the water from the dam to your home. So it's done through pumps, very heavy pumps, which need electricity, which need power. And then when you reaches then you have a treatment, water softeners, maybe water purifiers, which are used to these particular discussed earlier. Yet the built environment, can you go back please? Yet the built environment has received only a small fraction of climate-focused funding from research and development compared to other sectors. Although investments in the energy efficiency of building operation increased 16% among Group 7, G7 countries in 2021. Such commitments in comparison to what is required to decarbonize the built environment is very less. As the largest global industrial sector, construction also has a widespread social impacts. It is at the highest risk of forced labor with lax environmental and labor regulations tending to coincide. So there is lots of, with these kind of things, lots of people, NGOs, engineers, architects, they're working towards creating a particular ecosystem in which we get more conscious about the whole thing. We make sure that some actions are critically taken to reduce the emissions as much as possible. Many reports say that the kind of construction is going to double by 2060. Can you imagine the kind of emissions we're talking at that particular time, which is just, you can say, 35 years from now? In this absence of urgent actions, what is going to happen is the carbon emissions of common construction materials such as concrete, steel, and aluminum are projected to grow to increasingly dangerous levels. Although developed countries have historically contributed the vast majority of global carbon emissions, the world top 10 greenhouse gas emitting countries now include rapidly developing countries such as China, India, and Iran. Even with the implementation of widely accepted interventions, emissions from the built environment sector are projected to go far beyond what is allowable to keep global temperature rise within 1.5 degrees centigrade. This is the target which was called in 2015 Paris Agreement for Climate Change. So lots of solutions are coming in, lots of R&Ds are happening, and those particular things need to mitigate the rise of global warming, the rise of these emissions, and come to a particular reason. 1.5 degrees is a claustrophobic increase of temperature which they are envisioning in coming decade. Next. Now, where we are heading with these kind of developments, I'll give you some very interesting figures. Urban development is set to triple in the first 3 decades of the century, the largest cityscape expansion in human history. By 2030, 6 out of every 10 people will live in the city. This sprawl will swallow up a landmass nearly equivalent to size of South Africa. Majority of predicted urban growth, 55%, is expected to occur in our own continent, that is Asia, including a 1800 kilometers east coast urban corridor in China plus 7 state capitals throughout India. What is going to happen is it's going to consume biodiversity hotspots, leading to extinction of 139 amphibian and 41 mammalian and 25 critically endangered bird species. And we speak now, there must be at least 10% decrease on these endangered species, because the data which I collected was way back from 2020. By 2030, we'll need to produce 50% more food, energy, together with 30% more fresh water. You know, when you see these figures, what you gather, it's the claustrophobic expansions which are going on. Anything what we do today to mitigate these damages, collateral damages, they are less. It's not going to be enough to get things to the levels. You know, AQIs of different places. You go to Delhi, you go to Mumbai, you talk at any place in India, and many places in China also. You'll find these particular things are irreversible. You are just mitigating all these particular things day by day. So what is to be done? That is something which is more important for us. for a future. Future holds one thing for sure, and that is promise to live, to give a space for future generations where they can survive healthy and happy. And that is what we all are going to discuss today. And I'll also be sharing many case studies. Before that, I'll still like to go a little bit more deeper into the theory before we'll come to the various aspects of future sustainability. Next. So what has changed? So I just picked up a random, you can say, comparison between 1945 and 2015. So 1945 looks very, very neat, very sleek. So what we did was we understood a particular life cycle of a particular project. So right from extraction to production and to the life cycle of that particular production, or maybe manufactured, whatever it may be. And similarly, we saw 2015, we picked up the whole thing, what has changed. So this comparison shows you how things are being used to build with low carbon materials and what benefits we are going to get, because as you see the thickness of lines, it's a permutational growth in the needs for materials, biomass or fossil, which is required as the time grows. Given the increasingly furious pace and scale of global construction boom, the challenge of shifting away from carbon-intensive materials and methods often seems daunting and potentially impossible. But it is important to recall that even in very recent past, building materials were not always carbon-intensive. Up until mid-20th century, global materials flows were extracted overwhelmingly with renewable biological sources such as forest and agricultural processes. You can see in this figure. The vast majority of building materials were locally sourced, and buildings were specifically designed with climate conditions in mind. Biomass materials, which includes wood and timber, dominated the global construction. This is what happened in 1945, prior to that, early 20th century, alongside with earth-based materials until the latter half of 20th century when things exploded. It has only been in the last several decades that the majority of building materials come from extractive, toxic, and renewable processes. By the late 20th century, if you see, the preponderance of metals and minerals constituted the most used building materials for first time in human history, just three materials. Can somebody think about it? Concrete, steel, aluminum. And now what's happening is glass. These were responsible for 23% of overall global emissions, which happen today. With corporations across global sectors, we can alter this path. The shift towards properly managed bio-based materials could lead to compounded emissions, savings the sector up to 40% by 2050 in many regions. If you see the use of energy in the latter part of 2015 chart, how the use of energy is being mitigated by fossil materials and it's recycled at most of the places. To enable the shift towards new methods, it is important to understand what drives the decision being made at each phase of built environmental process. So we never look at any particular thing as a single derivative. We live and like to look at each and every thing in the life cycle aspects. Building materials, which carry enormous cultural significance. The reasons that society choose to build with certain materials over others are complex, but are driven by diverse social, technical, and economical factors. Common carbon-intensive materials such as bricks, concrete, steel, and glass are responsible for the image and cultural currency of cities, institutions, and houses. They reflect how a community has organized over time, what is valued during different periods of history. inside the buildings where modern societies increasingly spend most of the time. Interior finishes like wood, plaster, ceramics define look and feel of how people experience their homes and workplaces with significant implications of health and well-being. Can you imagine we are working, let's take a very simple example of residentials. When we proudly say कि हमारे घर में builder is giving Italian marble. Now, Italian marble itself is a natural material, which I would have loved if it was being used in Italy or something. But the process of getting the Italian marble from the quarry, import to a different part of land, say India, going to Silvassa to sort of treat it, you will be surprised the kind of water is required to cut these stone masses to the desired effects what we see. Amazingly kind of energy which is required besides water, which is required to process all these heavy machineries to get a sheet of Italian marble. And then again that is transported from that particular site to the godown and the godown to your site. So when we talk about the life cycle of building, you need to assess the whole sustainable aspect of using one material. So imagine there are 180 materials and specifications in one particular building for which you individually get, as an engineer or an architect, get pointed out. Next. But what's the way forward? What is that we need to do? We still like to use these kind of things. We still like to work on these particular principles, and we still like to proceed with these kind of things as and how it carries further. So what are the basic guiding principles of sustainability? See, any kind of future trends would not happen if it does not support economic growth. Any thing, any new R&D, any new conclusions, any new theories will only work if it's derived out of social inclusion. It cannot be worked out sitting in a lab or sitting in a silo and then work out and giving a solution to everybody. And most third important is a perfect plan for environmental protection using these particular things. This is how the guiding principles of sustainability move forward. So, go further. So once we talk about these particular things, we understand, we like to put it into different principles. So let's go from macro level to micro level. Macro level, may we talk about cities, we talk about urban designs, we talk about so many other things. So we talk about, let's say, compact and diverse urban forms. You have seen the lots of FSI being increased in Mumbai, Navi Mumbai, MMR areas, and so on and so forth. Hyderabad, I think, 1.5 decades back, declared that there will be no FSI. So what is going to happen? You think the projects and the environment can remain sustainable there? I don't think so. But then still, as I told you, our first principle, economic sustainability, the city has to survive. It needs people, it needs development, it needs construction, it needs to give spaces to people. So to promote higher density mixed use development, to reduce travel distance and preserve green spaces, new policies are being implemented at various particular levels. If you remember, some years back, a decade back, there was a high density scheme which came in as dental housing. So we can in fact go a little before that also. TDR. What was TDR? TDR was a way to put people, give them more FSI, put things into more perspective, make infra development more sustainable by selling the TDR and getting the funds to invest into the cities, and or preserve whichever biomasses are available at different places. Then came SRAs, some redevelopment projects, now coming to cluster developments. So all these urban policies are being formulated basically as a part of diverse urban densifications, which are happening at literally each and every part of the world. We boast the largest population landmass and high density landmass in the world. So we have to be more dynamic to create these kind of developments, well thoughtful. So I remember I think last year I was speaking on some forum where we said that the DP roads, the DP plans which come out along with the new policies like UDCPRs recently, which came for MMR, gave us a FSA of 4 to 9. Imagine a poor place which was just enjoying the FSA of 1.5 and a builder was fighting to even get additional 10% extra so that he can make more money. And all of a sudden there was a boom in these particular FSIs. So there's definitely going to have a very deeper impact of these kind of uh, developments, which are more theoretical. So what we said was, being a part of IGBC, I'm chairing IGBC Navi Mumbai. So that's where most of the forums started sort of putting a concept that why can't there be a DP infra? So why can't infrastructure be a part of DP when these kind of land use plans and FSI is being promoted? So that will help us to mitigate and balance our side effects of all these particular developments, which are going to be in the form of reduction of green spaces, it may be in the form of increase of uh, uh, increase in temperatures at the micro level, which will have more hard surfaces, more reflective solar discomforts, whatever it may be. So, I mean, there can be so many things which can be sort of preserved or mitigated at the right time at the right places. Smart and data-driven planning. We're talking about smart cities. We're talking about so many newer concepts in planning. We're talking about IoTs. We are talking about sensor simulations, open data, this thing. And now AI is giving us so much of flexibility in operations and responsiveness that you can't even imagine. Right from the way you use your lift to your kitchen to your anything, parking spots to everything. I think I remember when I did this NMMC head office in 2012, 13. That was the first building which critically implemented a BMS system, building management system, where we had even gone to the finest of detailing of adding carbon dioxide sensors and oxygen monitors and STPs and MEPs, all sort of mapped into a single room on different terminals to optimize everything: smoke detectors, fire detection, oxygen levels, you name it, lightings, firefighting systems. Everything was put under a single console room. Those particular things gave us a good real-time feedback about various things which were available in the particular building, like pani kam to nahi ho raha hai, underground tank mein pani jata hai, your STP is performing okay, XYZ, so many things if you go on. Now in 2025, I think we should have a data where we should analyze the usage of that particular building as a part of life cycle, which we can implement in. I don't know whether those softwares are extendable or not, but now the software whichever are coming are quite extendable, where these things can be put into analytics, and you can actually redefine the usages of all the common amenities which can cause indirect inflations of usage of energy. This building itself at that time was recognized as LEED Gold. I think this was the first municipal building which got awarded those particular citation. As we grew more into the macro form, we realized that the worst thing what is happening with every developer and engineer is provision of parking spaces. You need wider roads. You need so much of dead spaces which you need to create in housing colonies now. That is in the form of car parks. So government started thinking about it, because for every 100,000 square feet of development, a thumb rule came out that we need 35,000 square feet of car parking space. So that means affordability and sustainability is went for a toss to accommodate the needs of a human civilization. So a thing which would have costed you, say, 4,000 rupees a square feet started costing you maybe 35% more, maybe 5,200 or 6,000 rupees a square feet. So another concept as a diverse urban design format which came up was transit-oriented development. That is when I did L&T Seawoods at New Bombay, in which we started a particular thing that the whole complex, which is around 6 million square feet of livable and workable space, be integrated in and around the railway station. Benefits: people don't have to move out to work or to go to work. So you have a railway station on your project. You just walk down to the railway station and you go wherever you like to go. You want to go to a mall, you need not go and search the markets. It becomes a self-sustained unit, complex. If you just walk across your podium garden, you're into the biggest mall of New Bombay, one of the biggest malls of New. You want to see a theater movie on Sunday, you don't take out your cars, you just walk down. You be in your Bermudas, t-shirts, and just go and have that particular thing. So the kind of impact of these kind of developments, how you see, can reduce car dependencies, economize the black roads, concrete roads or asphalt roads, which we create, and have more green open spaces in and around the city. All these particular designs which you develop in the term of city planning, again, needs to be inclusive and equitable, which ensures that there is a quick access, an easy access, safe access to housing, jobs and services, and all the green spaces in and around that particular city are talking to each other. They're well integrated. So it's no longer that you have to walk on the road and you have to get down and you have to move ahead, so on and so forth. Then you have efficient resource use. Your whole building works on same 5 tattvas as a human body, water, energy, and materials, which should be used efficiently through the standards, the physical properties, and most important is used in a particular logic, which gives you a perfect harmony of circular economy practices. Means what? RRR, recycle, reuse. Now, when you do this particular kind of formats, you become very conscious about whatever we are using and around that particular thing. And this is the NCI hospital, which you see on the left-hand side, National Cancer Institute Hospital, which we completed in 2023. The whole, synergy between glass, which was used in facade, the water, which was used, demand, which was raised for this particular project, air conditioning load, which was put on this particular thing, they all spoke, like my facade engineering spoke to my MEP engineering, spoke to my architectural spacing. And when we spoke to each other, what we did was we saved 35% of water. It got savings by recycling. We were able to save a good amount of energy by use of performance glasses. When we were able to use less energy, that means we had less air conditioning units, means these are all water-based chillers, so less use of waters for this particular project. And you'll be surprised to know when we integrated all these things together, how the chhaja should be placed so that it's minimum glare coming in. We were able to save 27% of air conditioning capital cost on that particular building. And it becomes a part of economical practices, because eventually your building is not talking as glass is different and MEP is different and this thing is different, but they're talking as in a single language. Then city grows. So when city is growing and you're implementing all these particular kind of things, city has to have a resilience, adaptations. For example, your population is increasing with your FSI. Your climate risk keep on increasing. You are at more mercy of heat, floods, and storms. You know what is happening in North India. You know what is happening in Himachal. You know what happened in Gurgaon yesterday. So your infrastructures don't get you stuck up at one place. So you need to have a more dynamic modularities. I'll be talking about my project Nana after a couple of slides, in which I'll tell you what resilient features can we add to make the structure more robust and acceptable. Today, a very important concept of green and blue infrastructure, which is getting involved, which integrates parks, trees, wetlands, and water bodies to enhance resilience, air quality, and biodiversity. I mean, the similar kind of thing which you say, Jewel of the Mumbai in this thing. This is one project which I took in 2010, which we made a 15 years plan to keep on investing a good amount of ideas into that particular project by and clearing this particular thing. And you see how in 10 years, how beautifully that particular, in 14 years, how beautifully that particular piece of uh, infrastructure has been created like a city center. More than 10,000 footfalls happening every day. And most important is the sensitivity to sustainability. Let's not forget our cultural and social. So there has to be a social sustainability. Preserve heritage. This project I'm showing you is JSS. No, so this is not JSS. This is Majuli University. It's on a small island in Assam, near Assam. And they had their own culture. The whole university, when we created, we sort of used local materials. We wanted to preserve their heritage. Even the art forms which they create, this is a cultural university, so art forms which they called akhadas, how the planning is impacted into that particular thing. And most important is give spaces for foster community engagements. So with all these particular basic principles, I think you are ready to face a world to be more effective for a good sustainable future, not only in your designs, but in your in around you also. Go next. So let's say what changed actually. So you see, the 1960, this was a kind of office blocks. You may see in Nariman Point also the buildings which are there. They're very flat, Air India building, very flat, very minimalistic, very sort of sleek. So aesthetics was a keyword at that time. What changed? From aesthetics, it became how beautiful your building performs. So from looks and space planning, it became the performance of the built form. So these two are two absolutely different uh, partners going hand in hand nowadays. You still need a very efficient building. We are talking about efficiency of buildings in residential, commercials, and all those things. We like beautiful buildings. See it in New Bombay, go to Hyderabad, go to so many Gurgaon. You see excellent kind of constructions coming up. Though at times they feel more European or westernized than Indian, but yeah, they're aesthetically beautiful. But a new trend which started 20, 15 years back when people started realizing that, boss, this is not the thing, this is not the only thing. Thing is that I'm being very irresponsible to my neighborhood in terms of climate, in terms of use of my building. I'm not saving water, I'm not recycling water, I'm not doing this, I'm not doing that. And the whole concept changed that your building let the building be called beautiful by its performance. So over the time, a new concept which now got evolved is called zero energy building, zero discharge building. It's a neutral building, carbon neutral building. So these are the kind of concepts which started formulating, and these are the things which are being sorted out. So even our Prime Minister Modi, he said that by 2070, I think India will become a carbon zero. So a very interesting thing. I went to Singapore in 2014 as a part of IGBC. We were invited by SGBC, Singapore Green Building Council, and we had the worldwide, all the architects, planners, policymakers were there. And everybody was talking about, it will be carbon neutral by 2030. Like Canada said, will be carbon neutral by 2030. Japan said we're talking about 2040. And I was wondering what is carbon neutral. I mean, that was the kind of my exposure towards this concept. I'm just talking about 10 years back. And I started moving towards that particular thing, and we started propagating these things. And when I was in ministry for 6 years, I was actually started talking to people, what are you doing towards carbon neutrality? Good that you're using materials which are sustainable. You have your planning, passive architecture speaks very good about energy saving features. So that's but who is taking care of the performances of the building? And that concept was new. So we sort of started working towards stimulations, talking about each and every space which you create. There are softwares which are available. So we started talking about to prove that my building is more efficient than another building which was done 10 years back. So how do you prove it? So we started stimulating these particular sort of spaces, putting the particular thing, climatological perspectives, and coming with the particular thing that as a build form, this is how it is responsive. Then we started talking about water balance charts. This is how my water conservation is happening. Then we started using talking about basic ASHRAE standards which happen for this particular thing. All these particular things put together gives you a perfect building, which goes in next slide. So this is what happens now. Everybody's talking to everybody. It's not about a building as a standalone building. It's about everything, every concept of engineering which comes together to make your building stand out in the field of sustainability. This is my future. This is where I say my building become net positive. I'm not taking away from Mother Nature. I'm not taking away from my infrastructure corporation infrastructure. I'm giving it to the corporation. Our IGBC headquarters made, I think, 2 decades back was net zero at that time. Parivartan Bhavan and Environment in Delhi is net positive. So they talk about solar sort of covering. They talk about everything how it encompasses the whole build form to get these particular things. Your glass facades with lots of shades gives you the same effect as maybe cutting down all the glares and getting all the heat excesses if used properly. Your ventilation still plays a very important role, cross ventilation in any kind of space. You have technology to back up your designs. Your openable windows can be just adequately opening than to spoil complete efficiency of air conditioning in case the whole buildings are air conditioned now. Your storage tanks, chilled water storage or hot water storage can be used like hospitality using the hot water to recycle towards the toilets for baths also nowadays. So with all these kind of things which you put together, your water going, grey water going to get treated in STPs, again getting recycled and be used for domestic purposes, for gardening purposes, for other things. You come to a conclusion that you are actually saving more than 32.5% savings in usage of water. You recycle them into water chiller plants. You have more efficiencies happening. I'll tell you, air conditioning cost, thumb rule, everybody used to feel that, mere ghar pe 150 square feet would need 1 ton. That's like thumb rule, which we consider. Now we're talking about, can we do an ambient temperature from 21 degrees to 25 degrees because India is a tropical country. So you tend to move towards 25 degrees centigrade. So you have efficiency going to 200 square feet per ton. Then you again use some other hybrid methods to increase this particular thing. So like in NMMC headquarters, I used the central atriums, which is, if you guys have been there, so central atrium, they're all non-air conditioned, but you'll never feel the temperature more than 24 degrees, 25 degrees there. It's naturally cooled. Only the operational parts of the office are air conditioned. So I was able to achieve efficiency of 301 ton per 350, 400 square feet. So eventually what happens is your energy usage goes down when you compare it with 358,000 square feet of construction. Then you use facades which are used, which are performance glasses. You see the U and V values of that particular thing, which side, south side or north side. So you know how the heat intensity is taking place, the shades which you want to give. Shades can always cut down the heat gain from the windows. Lighting controls, if they are automated, so there is no waste of this thing. There are sensor movements which happen, which get tapped by the kind of people usages. So you can actually have a 0 watt working at the time of non-usable thing, and so much of technology which can actually sensor-based light fixtures can be used to put these things together. Then you have solar. You mitigate the whole use of energy through your solar. Uh, so these are the kind of concepts which you sort of put things into perspective. You create organic waste. You use the organic waste on your sites. So everything is usable. Nothing is a waste. Waste is no longer remains a waste. So that's the new integrated approach which we all talk about now. And that's where the future lies. That you exist and still there are no imprints. You exist without an imprint. So that's the kind of ultimate goal of any architect or engineer for the future generations to come. And that's where whole industry is moving towards the whole thing. So next. So developments kept on happening. We started coming to prefabricated modular construction. There was a flexibility, dynamic spaces, and uh, so much of advancements happening. You keep on understanding how much buildings can go faster. I remember recently did for Sitco, we did a Pradhan Mantri Awas Yojana. We were the PMCs for that project, and we were able to do a ground plus 12 building in 96 days. So those are the kind of things which helped me to put technology first. So that means we went for precast, we went for zero wastage kind of policy while working. So it was more of planning and less of execution, uh, and so forth. And that's where the world is going on. Recently, I think 4 months back, we did a ground plus 6 structure for Sitco again, uh, and that was done in 45 days. Again, precast. Okay, but these are post planes, like after you come above the plane. So that those are the kind of new things which are focusing more on efficiency and flexibility. That's where adaptability and flexibility, I say, is the new keyword for the next generations to come. Next, please. Organic biophilic design applications. See how beautifully the buildings are being swelled. Like I have visited this Bosco vertical in Milan, and I was told they have more than 150 species of plants which are placed on in this particular building. So that's where the outside becomes inside. And to be very frank, this photograph is taken from the net, but I went there. The next buildings to this particular things are all industrial buildings. Very contrast of the kind of construction which got developed into this particular zone. So basically, increasing these elements which are derived from nature into architecture with great sustainable impact. This definitely gives a very good kick to any kind of innovator or designer to move things towards a newer perspective where you no longer get dependence on what's happening outside urban design, but yeah, you self create a particular environment for your own self, environment which is healthy and good for you. Next. Small elements, you see the architects from time to time have been using. एक तो बहुत simple है. Your step terraces are in New Mumbai as earlier used to have it. All these step terraces were saleable. So builders के लिए तो अच्छा था, बेचते थे. But what indirectly it used to do? It used to give you a space for having your plantations, greenery. It gave you a space which acted as a sunbreakers to your windows, which were like which increase the efficiencies, cut the glare for the inside light quality within the spaces. And it also now gives you a lot many vertical spaces to have, even solar roll-on panels which can be used for individual flats. So you don't wait कि कोई मेरे लिए आके करेगा. This is your house. You can do it for yourself. Many new design concepts came in where new swimming pools were introduced. We're doing one project in Rajkot on the similar thing. That itself became a particular thing, recycled water being used again and again. So idea of swimming pool was leisure, which came as a concept, but when we worked on the water balance of the whole building, we realized that we can use this particular additional water instead of throwing to our drains, we can actually create these kind of. So I didn't have space in my ground level to have a large pond. We have a swimming pool, but I didn't have a enough rainwater harvesting pond. But we created swimming pools at every floor, and so on and so forth. Next. Then the roof gardens, Jade Garden, I think at Worli Science Center. You see that was initially in 80s, which was constructed by Mr. Kadri, and that was the first time when we saw the terrace garden at such a huge institutional site, and that also in a place like Bombay. Uh, so so lot many things started. Build forms started looking at that particular thing. You see this sort of a water bodies of the city started becoming a important part of a particular city, in which lot many moments, not only for leisure purposes but even for the survival of cities, they started looking at as a holding ponds, and total stormwater management system started moving towards, like all this. The third picture which you see is like biospheres being created in the landscape so that the water runs by itself instead of wasting construction materials on making stormwater drains and other things. So each and every element started, asking for some inputs from visualizers to put them as a responsible part of the built environment. So whatever we do now in the roofs or the gardens or other things, it comes with a purpose, and it comes with a very robust concept, well integrated between the whole complex. These are what the future is bringing us together. Where offices are bringing natures inside. There are lots of leisure spaces. They're not waiting for you to a lot many informal spaces which you see a lot many ID companies and all those things which they are integrating. Anything which stimulates the human senses, which stimulates the whole working environment. I think that's where the main focus is of everybody. So those are the kind of things which can be moved into the right kind of direction. Next. Public transport. I mean, you cannot have cars everywhere, and you tend to lose out on your walking space, and you lose out on your breathing space, and you lose out on your space. I mean, you can't lose out on these particular three factors at any given time. So best is have a robust increased public transportation system. London, you have tubes, we started a metro. Unfortunately, our increase of population is uh, comparatively much higher than the infrastructure being introduced in the public forums, that it gets so much absorbed at so early that it's not noticeable. But yeah, we're doing a good job. I think the infra over the time has been fantabulously integrated into our brownfield cities. But I think enough is less with the kind of population growth what we have. But I think the only thing which I see is that we really need increased public transportation, more build forms, and more uh, kind of interventions by at government level to have these particular facilities given to people so people get their own space in the city. Next, again, kind of sustainable designs. A lot many concepts are being happening, like bamboo nest towers, which are going to be ready by 2050. It was a kind of concept in which designers wanted to create a sustainable environment. You see the tunnels created with the energy generators, wind sort of tunnels created at different levels, a complete bamboo kind of roofing. The architect wanted it to be like a forest, the city vertical thing to be a part of a forest. So he covered the whole thing with the bamboo nest, and the biophilic design follows at different levels at different places. So it becomes it traps the wind energy through these wind tunnels, and keep the whole environment around the nest workable and usable. It actually invited more uh, birds and habitats to be a part of this particular built environment. So we have these particular micro urban forms which created by one developer to have a very different kind of philosophy of biodiversity within that particular residential areas. Similar on a different note, maybe another concept which happening in Brussels with lots of biophilia being a part of design, uh, very well integrated community inclusive spaces to put things together into different perspectives. Next. World Trade Center and Santiago Cartalawas railway station. I think you must have seen this particular thing. Another very what do you call aeronautical design for the it's between a very dense city, and I feel that this kind of space aesthetically definitely stimulating, but it has a very great flow of wind which happens in and around this particular area amongst the top skyscrapers which are moving, and then this Halmoni building in Hamburg. I was there and I was finding it very surprising that what was that. And then I was told the history that the red part which you see, the terracotta part which you see was actually the industrial house, and later on they wanted to convert it to the commercial, and but still they wanted to preserve the heritage. And the architect came up with a concept of a reflective glass that still in the particular environment and built form around you don't see a new building because there's a reflection of water on the upper surfaces, and the build form remains intact the way it was with minimal interventions or modifications. So different kind of concepts worldwide. People are experimenting and putting things, doing their part of the job. The Venus project. These are floating cities which are being created totally 100% solar and recycled water and usage of the seawater converting into drinking water, waste being converted into the use for this particular project, and so on and so forth. Quite futuristic things happening. I think we can go to the next slide. Parametrics, another things you see at Scraper, where Manhattan, how the buildings have been transformed by these kind of interventions derived out of the parametric structures, that pyramidal thing. He actually increased the number of windows, the face, which face the increase the surface area of the buildings in such a way that more in the same triangular form, he actually increased the whole thing by 18% or I think 20% by these forms, so that more inner spaces get natural light. So so lots of tech and softwares being used today to get the maximum benefit out of whichever limited spaces we are left behind for developments, which definitely, no need to say, become a very effective tool once you analyze what you have gained out of the whole process. Next. So this is a again sustainable innovation infrastructure which actually reduce the driving distances between two cities, which were approximately used to take from Skyland to Trondheim, which is going to get completed, I think, in a few time. It's a length of 27 kilometers, covers through the water, self-sustaining. So it actually is a very interesting project because the whole project was created out of buoyancy. A very specialized kind of techniques were used. There was no anchorings. In fact, the things were floating and upward, upside. So this is something which you're all waiting for. This was actually made 30 meters below the water level. Next. So after seeing all these things, so what comes to your mind? I think I find myself to have a very clear mission. That is, let's shape cities that inspire innovation, foster resilience, and enhance the quality of life for generations to come. What we do a sustainable, adaptable, and people-centered designs. The last 30 years, we built cities. Now we are responsible architects and engineers for the future and envision the urban landscapes which are responsible enough. Next. So let's talk about a small case study of my new project which is coming. They say NANA is the start of Mumbai 3.0. NANA stands for Navi Mumbai Airport Inference Notified Area. Next. So you see the transformation of cities. I'll make it more contextual because you'll recognize all these particular things. You must have gone through these things. Urbanization has taken Mumbai and MMR to a different level. There's a huge surge of population density. So infrastructure always remains in demand, that you have to keep on elevating the infrastructure, which is shaping a futuristic urban landscape. And needless to say, needs of bottomless investments from globally different parts, which will reshape our cities physically and functionally. Next. So this is the kind of thing which was there in NANA earlier. So this is when it was in 2013. When it came, there was a new sort of part of CITCO which was called NANA, which covered many areas, which was around 25 square kilometers radius from all the sides. And from time to time, development policies came in. Some part was given to MSRDCA. Some part was given to MIDC. Some part was given to even MMRDA recently, Hope and all those areas. And some balance is left. 260 square kilometers is left with NANA. Now, these DP marks were made somewhere in 2013. There's so much of development pressure because Mumbai was dying at one particular stage. So idea of MMR was to enhance this particular thing. Navi Mumbai was created with this particular philosophy, but somehow it got tagged as a poor sister of Mumbai. And I think remaining docile for so many years, it found its ground and now today become a very robust development part, not only in Maharashtra, now in India. I think I can say very proudly that we have the maximum kind of developments, promotions which are happening today, and a very successful rate of transactions which have promoted very robust infrastructure created by CITCO and MMC or even PMC to some effect. Next. So this was what it was. It was only Vashi Bridge earlier, and futuristically they, in fact, thought that Atal Setu, what we call it, was actually, you'll be surprised, was sort of envisioned around 30 years back. In fact, 35 years, 40 years back. And it just saw its existence recently. The kind of mobility benefit it gave to everybody was tremendous. So a new airport was being created. It got created. It is being integrated between Mumbai and Navi Mumbai now. The whole kind of belt is seeing a surge in development, not only along this particular belt, but 360 degrees. So NANA is a part of this particular thing, and we realize that why NANA should be successful, why it should not be successful. We did many demographic studies, we did many things, understood what's happening into this particular area. And finally, this 41.75 kilometers, which we got the project as a part of NANA, is out of 250, it is only about 41.7 square kilometers, which we're designing, which is called TPS schemes. Next. So it has a very interesting DP sheet, and by looks of it, it looks like a Rangoli diagram, as I always say, yellow, green, orange. And when we read the GDCR, we used to find it very funny what the spaces are, what is growth sector, and what are these things. But we realized there was a logic when we did that, when the plan would have been made, that it had 42% of residential area, a very robust transportation system, 20% was already allotted. Then commercial space to 14%, non-development which had rivers and unworkable mountains, hill slopes, were there 6%, which is very high. Green spaces we let for 12%. So we knew that 12%, 6 by 18% we're going to have it open, and then for 20% I'm giving a road anyway. So it's going to be 38% open spaces. And this was like public and industrial. So there's no industrial here. So public and social facilities put together. So what were the objectives which we thought will make it future ready, which will be for our next generations to come? So we've seen the development of Mumbai from 1971 to 2025. We're talking about something which is starting in 2025, and I'm sure it will go to another 50 years. So we're talking about 2075. So what are the basic principles we sort of integrated? So we did some tweaking in the whole DP, and where the focus was very clear that we wanted to give future-proof planning. We also wanted, with the kind of surge of tech and everything happening, we wanted to facilitate speedy development of economy so that before they go to Hyderabad or Bangalore or Delhi or Pune, they should first come to New Bombay. So that's the kind of readiness which we require in terms of infrastructure and sustainable sort of ecosystem for the whole thing. And when I was talking to you earlier about inclusiveness, of course, you need to create an environment which boosts mental, physical, and social well-being of the users and the citizens. So we had a very simple strategy that we wanted to assess the present and future demand. We thought, let's assess the feasibility of resources and proposed development. Like, very simply, when the project was being conceived, as per the GDCRs, at that time, the FSA was 1. And today, I know when I'm sitting in 2025 and seeing the adjoining area half a kilometer away is adjoining UDCPR, which is giving me FSA from 4 to 9. So what should be my readiness for this particular project? And the whole concept goes for a toss. So we thought, let's assess and see what is designed presently and what can be the future demand. Then create an incremental roadmap. You align with various guidelines given by state and national NDCs. Create a transition roadmaps which were thought earlier. For example, when the FSA was low, the thing was being designed for 12 lakh population, 1.2 million population. Now I'm talking about 3.2 million population. So what are the transition roadmaps which are going to happen and how it is going to be effectively implemented? So efficiency targets, how it can be achieved in design and its policies, which we are going to create. How do you ensure affordable and reliable, secure accesses with resilient investments which people appreciate, people get accustomed to? And then finally, when these all things are done, how do you monitor, review, and renew from time to time? Because things will keep on changing. There will be new concepts, there will be new this thing. Only thing how we can do it, we know how to track the data, we know how to monitor the review and renew the performances and targets from time to time. At the same time, it can only happen with a very strategic, dynamic structure which we create now for collaborations in coming future between each and every elements of the city. Next. So we also sort of started talking about the connectivity. We analyzed how much connectivity spaces we have. Metro corridors आगे कैसे आ रहे हैं, rail corridors का क्या future है, express highways कैसे बन रहे हैं. All these particular things and how these particular things will affect my city. We have multimodal corridors from 100 meters coming in. Delhi freight corridors coming in, JNPT connectors, airports, so many of dynamic spaces in and around there. How do you put this particular thing so that I'm going to reach everywhere in 15 minutes? Go next. So what other things we can add to is make the city more robust and more acceptable to people with different strategies. Make iconic landmarks in terms of urban form. Choose those particular urban forms which becomes the city centers of that particular project. They should not be on the side of the road, they should be the focal of the road. So give better space for living where city gets its identity and branding. Every TPS can have its own identity. it can have its own existence. Natural resources which are available can be taken as an opportunity to create a full leisure recreational space for people, like in Paris. Next to the river, you can have the promenades developed. We had an opportunity of doing the same thing in Gandhi River. Similarly, to avoid to add on and being resilient to add on more population in coming time, do a world flood mitigation measures right now, assess what uh, effects the population growth is going to have, and activate these particular strategies to redefine the river fronts in terms of the depths and the quantity of uh, discharges or the quantity of water they'll carry in coming future, because finally the whole city's stormwater merges into the endpoints to these particular things, to back to the creek, back to the ocean. We've added the prefab integrated MEP systems into the different corridors, which are giving me a faster quality durable construction. No digging of roads in future. You have all the points happening on your site. So breaking the road becomes a punishable offense. They dedicated cycle tracks and wider footpaths. I call them green corridors. Again, remove the dependency on the road networks, improve more walkable and cyclable sort of pathways for a better city. Create lots of underpasses so that you avoid crossing the roads, so that you have a safe crossings for the children and the different age groups of the population in that particular area. Next. Create flyovers or major junction roads so that you avoid any kind of waiting. Waiting traffic itself is a big pollutant. So how you can create this particular thing, make the driveway more efficient in terms of time. Uh, now have a new Mumbai airport coming up. Create a airport as a hub and get it connected to the biggest secondary hubs which are being created from places to place, like Nana, maybe Corporate Park, maybe AeroCity, maybe City, so that all these particular things becomes a spoken hub kind of thing for my city. Waste management, more we do it, less it is. We have been able to achieve and reduce the fresh water demand by 33%. As of now, as I told you, how the green spaces can be added to the whole area. So whole my forest areas and playgrounds, which have been placed in a part of urban design, are like sort of well connected with each other, and they move forward in a particular way that they become the lifeline of the city rather than the roads. And this is, I think, what I learned when I did the case study in New York, Central Park, which I found that a lot many ingresses and outside and connects to different blocks in a linear way. We have one third the Central Park in Naina. We have uh, two times bigger BKC happening as the growth centers in Naina. So I think I found it very interesting to how to mitigate all these particular things together, that my dependency or movement on roads are reduced and city become more interesting to live and stay in. And finally, the government guidelines of ESG, environmental, social, and governance, how we can have the holistic view towards sustainability. So, as we're talking, we created external links. We found that the cities were being talked about in a very independent way, that Nana is different, airport is different, Panvel existing railway stations are different, Kharghar is different, KTLR which is coming is different, Vashi is different. So the connectivity which was there, lots of dependency on the earlier thing. So there were some projects which I thought, if gets extended to these connectivity points, can reduce the travel. So we found out a missing connection. We call it a missing connection project of 29.77 kilometers. Go next, which helped me to go next, which helped me to sort of define that from MIDC Mahape area, my travel time to this particular area from 50 minutes to reduce to 18 minutes. From Belapur, it reduced from 28 to 13 minutes. Taloja MIDC from 26 to this thing. NMI 26 minutes to 15 minutes, MTHL 35 minutes to 17 minutes, and Rasaini Padalganga 20 minutes. So imagine the whole city becomes 15 minutes connected. So don't you think that itself is a big kind of feature which actually would improve and make a particular development talk about sustainability in the most loudest of words? Next. Then we created all these particular kind of hierarchy of roads where we thought, why should be this traffic lights? Every time, damn stupid, we wait for 20 minutes on traffic lights and nothing happens. All the major roads were like 30 meters above, 45 meters, except for the city internal roads, which are like 20 meters and 50 meters. Every road we have made it without the traffic lights, no signals, flash-free movements, one-way systems. So you increase your driving speed from 60 to 80, 80 to 100, so that these particular things, your averages become good, your time is saved, and you can call your development more efficient. These are the kind of smaller kind of graphics which I can say we created. Then at the same time, do I only need buildings to make my spots in the city iconic? I mean, they are sustainable in a particular way, performance-wise, yes. At the same time, appealing? No. So how do I make it appealing? So every 13 or 14 of crossovers which we created with a concept. A very free-flowing kind of concepts with LED lights, and so they become a city brands. So they are the brand. Like you see one bridge in Bandra Sailing Road, which you find it very iconic. You see Atal Setu Bridge, you find very iconic. But how many years with kitne two bridges? So this is the time when we're creating something new. So we futuristically we've designed these particular things right away. Next. The grade separators to people movements of social cultural interventions where all the spaces, negative spaces or white spaces which get created here get used in some way or the other. Next. Your Gadi River ke upar se you have these kind of structures going in, so how you can make it more interesting. So that's the kind of interventions we're sort of designing right now. Next. As I told you, lots of pedestrian underpasses we have created. So at any given time, if my child has to go from school to home, he doesn't have to cross through this particular thing. We have created pedestrian underpasses. We have also created some junctions which we call it traffic calming measures at the upper grade level, where minor cross junctions to effectively manage traffic flow and ensure safe conditions for the thing where we are not able to cross it over. Next. Lots of underpasses like this again become like a social places for people to move in. Road junctions, we sort of graded the levels of the particular roads or service roads and the main highways for the safety. We've used the sections for using services together, and as you see, the main roads don't have walkways. On the walkways and footpaths are on the service roads, which cater to the residential areas. So there's a free pass of vehicles on the main spinal roads. Next. Future provisions, we kept it right now that whenever the metro has to come again, things do not go for a toss. So we've actually kept medians in such a way that the traffic is not affected the way it is affected now, because no services gets affected, nothing. It just that you barricade the one side and you start doing a precasting in coming time for accommodating the future needs. Next. Couple of sketches. Air buses which we've created, junction points, all the typical details, urban design of each and everything that the city is merged into a very interesting kind of detailing, which moves from one thing to another things. I go to urban and we worked out utility cross sections next. So this is how we have created the city level now. So these are all precast stormwater drains. So effectively, I'll tell you a very interesting thing. Like we had the Khadi River, which is very good for now. But 30 years from now, we didn't know that the capacity needs to be increased perhaps for for all the water bodies which are available. So what we did was we have actually took a technology which we were with all the LT and HT. Generally, what you see there, they're very separately put services. So we integrated the whole thing in a particular thing that we were able to save 40% of space and reduce 2 meters of height depth of excavation with this kind of tech. So cascading effect is that your excavation at one point is reduced, less concrete and less materials are used for the same kind of construction. When it goes to the river, the final river, there is minimum intervention required at Mother Earth's level where you have to change the course or increase the depths to beyond 4 meters or something. So we were able to sort of do it in 1.5 meters only, and so on and so forth. So these kind of have a very, affects on literally every part of a particular city because water levels are fixed. We have blue lines and red lines. We are predefined. So we know when the flood is right, we should not have another 26, 11 what happened there during flooding time. And same thing can be avoided by using more smarter technology in and around. Next. So that's the kind of sections which we created. And now each and every detail I'm showing you is that these are a part of my sustainable interventions when we are designing a particular city. Same space, same number of meters, and same things which move things together. Next. So then we also worked out a strategy. As I told you, lots of energy goes in distributing water. So we try to work out how the ESR can be created and GSRs put into so that we have minimal pumpings required for these particular plots. I think 80% of the efficiency we receive by natural gravity, and we're working on certain terraneous plots which get available to us where we have to put the pumps, and that's where the reverse slopes are coming. And those are the minimum points where we have to add and be dependent on the similar kind of thing. Next. Similarly, water transmission network, minimum of kind of things. So we call it water management. So what we're trying to do is we have already started a dam work called Thane Dam, which is phase 1 is 250 MLD. So water supply is about. So when we are actually working on the whole system together. So immediately for my 10 years, I'm going to get a tap from NIMC. Maybe next 5 years to 7 years, my Kontane will be ready to 50 MLD and my whole project gets enough water and 24 hours water supply. So every phase would be approximately around 10 years each. Similarly, we've created a feeder main, one single, which is around 45 kilometers. It's a huge sort of endeavor which you're carrying right now for adding to these particular water management. So next. Then we started talking about why even to waste the space of what we create in terms of ESR. This is what you already have seen in the city. So we are contemplating a new creative approach towards it. Go next. So can we make it as a project which becomes biophilic by itself, which has horizontal greenery ki jagah, it has vertical greenery in and around. So it has an environment for people to be inside and inside can be used for people to use. Next. Something. So water body in nature, this can be like exhibition spaces for people, informal spaces for people to move things together. Next. Another kind of designs. So lots of innovative designs are being done to put things which make interesting. Similarly, STPs, all the water can be recycled. And so the phase 1 what we are designing is till 2057. At least we can cater to the requirement of whatever STPs we are creating. Next. Then green features at soot levels, at building levels, what we are doing at infra levels, we have lots of detention ponds, swales, permeable pavers, which we are adding into our green corridors. Total length of network, we're still working on it. But yeah, but the principle what we found is we can have 30% concrete and 70% can be green biofuels. Similarly, when we come to smart infrastructure, we're adding lots of prefab components of stormwater, smart intersection with cable system, biofuels, IoT sensors, energy, BMSs, EV charging roads, and all those particular things. So that all the particular things integrated into one thing. And as a ESG strategy and net zero strategy, we're investing a lots of thing in renewable energy, promoting cycling and public transportation, and creating a solid waste management system as robust as Denmark Copenhagen system, which by investing a good in sustainable infrastructure and promote sustainable construction practices. Next, waste circular economy approach. So, and all these particular things integrate well into putting things together. Solid waste management is also being taken care by right from day one. So all the city streets are being designed in this particular thing. Where in fact, to a small portion, we are even trying to work out a pneumatic system for smart underground collection system in a small patch and see how it works. Okay, next. As I told you that Copenhagen is one of the fantastically 440,000 tons of waste which gets treated in terms of electricity, which is a 7.9 megawatt, or maybe Dubai WT plant. I think MD was recently in Copenhagen to see this particular plant, and we all are inspired to include something like this as a part of PPP happening in our city. Next. So finally, my friends, I think let's agree with the Dalai Lama Sahab saying human use, population, technology have reached that certain stage where Mother Earth will no longer accept our presence with silence. So I think let's work hard and let's work towards a very sustainable future and be proud of what we create. Thank you.
Thank you so much, sir.
So if any questions are there, we can take it for 5 minutes, and or there are no questions as such in your format.
Actually, sir, I will be asking them if to share the questions with us, and I will convey it to you later if any
Sure.
questions.
Not a problem. Thank
Thank
you,
you,
guys.
sir.
That's really thanks.
So on behalf of BVIT, I extend our sincere gratitude to you, sir, for delivering such an insightful session on futuristic and sustainable high-performance development. Your presentation not only showcased your remarkable expertise, but also offered us a visionary outlook on how cities can evolve sustainably. The way you combine practical experiences with futuristic ideas has truly left us enriched and inspired. Thank you so much, sir. Thank you so much.
Thank you.
Thank you,
Bye-bye.
Sethi साहब. थोड़ा मैं I was busy in the hospitals का थोड़ा था.
All well?
आप मेरे बोलने पे आए. That's a very important thing for me. Thank you very much,
So,
sir. Thank you.
so kind of you to have invited, sir.
Thank you, sir.
जरा पौने 7 से मैं join कर पाया था आपको.
No problem, sir.
I was busy. चलिए sir. Thank you very much.
Thank you. Thank you. Bye-bye. Bye. God bless.
Thank you, sir. So with this, we conclude this session. I request all participants to remain in the meeting since we will be starting the second session shortly. Thank you so much.
फोन किया था ना इसके साथ बैठा था. बोलना चालू करता है तो रुकता नहीं है. टाइम 7:30 बजे.
Ma'am, can we start? Saili ma'am? Saili ma'am, we can start the session now.
Good evening, sir. I am audible.
Yes, ma'am, you are audible.
Good evening.
Good evening, all. For the second session today, we are honored to welcome Mr. Shrikant Varpe, sir, a senior professional with over 18 years of experience in the construction sector. He is currently the Zonal Head Technical Service at Skyland RMC Infra Mumbai, where he leads teams in quality assurance, process optimization, and product innovation. With his rich expertise in project execution, value engineering, and training, he brings valuable industry insights that will greatly benefit this faculty development program. Welcome, sir. You can now deliver the session.
Thank you, ma'am.
Welcome, Mr. Varpe. I'm Principal Tandana.
Hello, sir.
You can please continue. Thank you.
Hello, sir.
Thank you. Thank you.
So you can share the PPT from your side.
Okay, ma'am. Hello, everyone. Today, my topic is on concrete mix design and how it is applicable for our smart city. Basically, before going for our what is actually mixed design and all, let's understand first what is concrete. So you can see now, nowadays we know there are a lot of materials available in our market for which we can go for low strength concrete up. So basically, in our syllabus, if you go through it, we are knowing that the concrete is known as a mixture of aggregate, cement, sand, water, and admixtures. But basically, I have one question regarding if some of the elements are eliminated from our concrete. Suppose we eliminate the fine aggregate, can we define it as a concrete? So most of the people says when we eliminate the aggregate from our concrete, we can't define it as a concrete. We can define it as a mortar, but not as a concrete, because as we go for a high strength concrete, mostly eliminate the 20 aggregates or coarse aggregates, or sometimes we have to replace the aggregates with some another material to have a high performance concrete. So the definition of actual concrete goes on change. So what should be the actual definition of concrete? So I've gone through a lot of literatures and all, and I found the one definition which suits perfectly for our concrete definition. That is, if two or more materials, when combined together, it solidifies and gives certain properties. That can be defined as a concrete. So for our smart city, we have to go through a lot of varieties of concrete, types of concrete. That's why this definition is most important. Because if we go for a pervious concrete, we can see that there is no fine concrete. We also say it's a no fine concrete. And there we are eliminating the fine aggregate totally, which makes it property as a pervious. So there the
Sir,
definition has to
sorry to
suit.
interrupt
Yeah,
you.
ma'am.
Actually,
Yeah, ma'am.
the slides are not being shared. Can you share it again?
Okay, okay. Is it available now?
Uh, yes, sir. Yes. Yes,
The
sir. You
change
can
of slide you
continue.
can see, right? Okay. So as I'm saying, in our smart city, we have to use a different various kind and a different type of a concrete, which has its specific properties. Like I said, it's a pervious concrete. We are eliminating the fine aggregate totally. So as per its specification or as per its requirement, the definition of concrete is not suitable at what we have in our syllabus or with what we have in our actual textbook. That has to be changed, or that has to be understandable that earlier it was okay with the definition whatever it was earlier mentioned in our textbook, or it has to be new change in the definition also should be done. That is, as I mentioned, if more, if there is a mixture of two or more material combines together, solidifies, and gives certain properties, that is should be known as a concrete. So I have actually break down these two words, that is con and crete, where con is a mixture of two or more materials, and crete, actually you must have read a lot of concrete types. There is a paper crete. Uh, so this type of a crete, when we say it's related to the solidification of a material and giving certain properties. So as we go on for our smart city concrete, which is not a normal concrete, it has to be some more properties in it. Like it has to be a self-healing concrete. It should also have a self-selling concrete, and it also should monitor the features around the concrete where it has been placed. It is just not the high performance concrete with the normal aggregates. It should be involved with a very particular aggregates such as the nano aggregates. Also, it should be implemented with various cementitious materials which are nowadays available in market. That is a you can say alcofine is there, nanofine is there, nano alco materials are there. This type of materials will not only improve the primary properties of concrete, but it will enhance as well the later on stage properties, that is the durability, and also sustain the material which is requirement for the future. Like if we go for a cement, that is OPC and other prime cementitious material earlier, right now it won't be last long for a future generation. That's why the replacement of cementitious material should be done with a supplementary cementitious material, so that it will be more sustainable for a future generation. And also, as we sustain our original primary material, it will be helping our environmental condition as well. So if we see, there are a lot of concrete mixed design type. There is a IS type, there is a DOE, there is a is the development of Department of Environmental Method, RRL, that is a Road Research Laboratory. So before going for actual mixed design, there are a few changes which has been done in our Indian standards. It is very important to understand it. So what the major changes has been done considering the latest environment condition or exposure conditions or the ongoing constructions of in the country, there has been a lot of changes has been done in IS codes. So let's first just go through it because implementation or understanding of our IS. So before going, I will share this slide that is Amendment 4 has been adopted, where earlier there in clause number 5.3 regarding the aggregates, it was used to say only the natural aggregates can be used as possible as in our construction industry. But this has been changed as 2016, there has been a lot of new aggregates has been implemented. That recycle aggregate, alkaline aggregate has been introduced, which can be used for our construction as per the requirement or as per the specification of our concrete. So not only just natural aggregate, but now we can go the different type of aggregate as well. This has been changed in a new amendment. There is a clause for 5.3.4. It has been specified that that's earlier the fine aggregate should be batched separately, but even if we can have an all-in aggregate also, if it is specified. But now it has been totally mentioned that coarse and fine aggregate should be batched separately only. Then there is the for 5.4, the water. It just has been earlier it was not mentioned that whether we should go for a treated water or a natural water. Earlier it was just mentioned that water should be used, it should be free from injurious amount of oil, acid, alkaline. But now in new amendment, they have mentioned that this water which is going to be used in our concrete can be natural and it can also be a treated water we can use. Only the things which is as it should be have all the testing and all the parameters should be set. The treated water or natural water both can be used for our constructions. During our mixed design, it was mentioned that seawater is not at all recommended as it is harmful for in our system. The same has been mentioned. Only the difference is now we can use in our curing purpose for a plain concrete. Earlier, it was not mentioned that whether we can use it for a curing purpose or not. But now this can be used unless and until it is under specified conditions. The major change which has been introduced in our IS code 456 is regarding the admixture. There was no clause regarding the admixture should be reused or redosed. Now there has been this clause has been introduced where an admixture can be redoses only under the special circumstances that the supplier and the vendor or the who is going to have the concrete, they should have a mutual understanding that this redosing can be used and it should not hamper any quality of our concrete unless and until both the purchaser and the supplier or the producer have a mutual understanding regarding the redosing. This has been the major change because earlier used to be rejected and it was not all the losses were there. But now because of this redosing, But the care should be care should be taken that it should not hamper the quality of concrete on a later on stages. Now, the grade of concrete has been a major change in our IS code. Earlier, it was around M80 only for our grade of concrete. In table number 2, it was only up to M80. And now there has been changed up to M100. Earlier, it was, you can see, I will just make it a larger one. Or I will share the photo. Uh, you can see that earlier there was this only 3 type of grade was mentioned. That is a ordinary concrete, specified concrete, and high strength concrete. The difference was earlier the grade of concrete from M for the standard concrete was mentioned up to M55 grade of concrete, which has been changed now. For the standard concrete, we are considering the maximum grade of concrete is M60. The high strength concrete earlier we used to consider up to M80 only, but now we are considering the high strength concrete up to M100. That's a major difference for a grade of concrete has been mentioned. There is no change in a general 8.1 clause, but there is a slight change in table number 5, note number 3, that is the minimum cement content, maximum water cement ratio, and a grade of concrete has been individually referred for all the type of exposures. Now, this has been a major change now in our mixed design, which can be used. Why I'm showing all these things? Because if we are not into the basic, what are the changes has been done, there are possibilities of not having a sustainable or not having that cost-effective concrete we are going for. Because as we say, concrete mixed design is again a cost benefit with the proper quality of a concrete and the specification which we required. So if we go through it, that 8.2.5.4, it is said for alkali aggregate reaction. Earlier, there is no major change in around Na2O or these things. It should be around 0.6% only. The total alkali content is around 0.6%. But the change in is around for the use of fly ash and only the use of fly ash. That earlier it was the fly ash can be used only 20%. Which has been changed now for at least 25%. Slag has been the same, it should be at the most minimum 50% can be used. This was a major change. Secondly, if it is earlier for a drainage system, which is not actually related, but as it is in the clause I have or suitable covering the drainage or lowering down the drainage, which is in contact with the alkali concentrated or site. But now it is mentioned that we can use a suitable impermeable barriers. Now this can be a major difference for our concrete mix design. That is a clause number 9.2. That's a concrete mix design. Earlier it was as I will not read all these things because it will take a time. We can go through our IS code or amendment. We will have that one, but I will just briefly mention what is the actual change in 9.2 clause. As it is mentioned that method is not the important. Important is what we are getting out of it. What the design, whatever the design we are getting, it should be proper as per the specification. We should have the properties of concrete. We should achieve the properties of concrete. But now the slight change in this content is whoever is preparing the concrete mix design, if someone asks for the relative values for where he is getting the values from, then that person who is designing concrete mix design has to implement or has to introduce the graph shown using the cement content, the fine aggregate and aggregate content, as well as why the mineral admixture percentage he has changed, selected, and what is the criteria for he has selected for chemical admixture. Earlier, it was just you can just submit the mixed design with the proper values. But now there is it is mentioned that if someone demands for graphs or the proper tables, then it has to be implemented or it has to be introduced in our mixed designs. Be benefit for us. In point number 9.2.2, it was just a change that the proportion of grading can be considered with the ultimate trial and error basis, which was not earlier mentioned in clause number 9.2.2. The same thing is both the paragraphs has the same thing. Just the difference is the proportion in grading of aggregate can be changed according to the trial basis. Now, as I have earlier mentioned, for the standard concrete, the grade of concrete was up to M55, and now in our new amendment, it has been it has been increased up to M60. So there is a standard deviation which has been introduced for M60, which has changed now from earlier to recent mixed IS code. Now, the batching system is not actually so much change in it. Only the things is the larger than the concrete plant, which are having a automatic batching and mixing plant. It should be properly calibrated and should not have any differences between the values which has been mentioned in IS 4926. That is for IS 4926 for ready mix concrete mix design. This is the IS code for ready mix concrete mix design. These are the few equipments and which is not related, actually related to our concrete design. It has been mentioned that the percentage should be between %2 to %3 for cement. It should be for 2% variation, and for aggregates chemical admixture, yes, it should be almost 3%. Only the difference which is added is the mechanical and a knife aging system, which is in RMC, at least should be checked once every 2 months, and for electrical loading system it has to be checked once in 3 months, which has been earlier not mentioned. Now it is mentioned in our IS code 456. There are a lot of changes that I'm not going through all, which is I will say just mention which are more relevant or more effective for our mix design. Now we will go for actually what are the steps involved in our concrete mix design. It is a similar to our earlier mix design, but only few revisions should be done. That's why I've added this slide. Now, before going for any mix design, we know the properties of our material, which is available at our site, and also what are the requirements for the from the client. That is what the strength is required, what is the workability is required, and then we will go for the steps which are involved in our mix design. That is, first we will find out the water cement ratio with respect to our strength and durability. Then we will go for finding out the water content according to our MAS, that is the maximum aggregate size. Then we will select our cementitious material, that is whether we are going for a fly ash content, or whether we are going for GGTS, or we are going for a triple plane, or we are going for a more microfine material, that is microfine like alcofine, microsilica, or microfine materials. We will select it accordingly. We will have a percentage difference replacement for the OPC, and then we will have a final amount of our cementitious material. As we having our water content and water cement ratio, we can find it out the cementitious quantity. Then after finding out the cementitious quantity, we will go for estimating our coarse aggregate proportions, that is with respect to our zone maximum aggregate size and water cement ratio. This was the normal concrete mix design. I will show to it later on. I will explain you with Excel sheet. Now, before going for self-compacting concrete, why I mentioned this self-compacting concrete, because nowadays when we see a high performance concrete with a high slump, it's ultimately transfer from self-compacting concrete. Yeah, we can say a self-compacting as a high workability concrete, but it is not necessary that high workability concrete should have a high strength also. But when there is a high strength involved with a high workability, it has to be SCC. Okay, so if we go for SCC, we are not going for normal slump concrete. We have to go for a flow, and it is important to understand what are the specification, or what is the differentiate or classification of flow concrete. That is it is mentioned that class is SF1, SF2, and SF3. There are three classes for a slump flow, which is from 500 to 850. If we see, SF1 is from 550 to 650, SF2 is from 660 to 750. SF3 is from 760 to 850 mm. This is what we are measuring from slump flow through a flow table. Okay, and there is one more thing, and it is that we have to consider that 50 mm round, it has to be crossed within 3 to 5 seconds. Now the second thing is, not only we are measuring the slump flow, but we are going for the understanding the viscosity also. So for that we are using a V funnel, and when we drop our concrete in our V funnel and release the concrete from V funnel, time taken is most important. We measure the time from emptying the concrete from our V funnel. We are measuring how much time is required for a concrete to empty the funnel. So it has been classified by two classes, that is V1 and V2, or you can call it a VS1 or VF1 or VS2 or VF2. It is said that T500, that is the early time, that's the initial time, it should be 2 seconds, and maximum it has to be 8 seconds. But for V2, it should range from 8 to 25 seconds. We can consider whether it is if we open the below gate of our V funnel, the concrete as soon as it release, the concrete will get flow through our V funnel, and it should range from 0 to 8 seconds or 2 to 8 seconds. It should range. But when we are keeping for more time, that is around for 15 or 30 minutes, then it should have the viscosity from where the concrete is taking a time of 9 to 25 seconds to empty that V funnel. That is 9 to 25 seconds. Then we are also measuring the ability of passing ability from this is all the specification earlier. Earlier was from FNARC. That is a mixed design used to be we conduct before we are having the IS this mixed design method in our IS code. Earlier we used to follow the FNARC steps. Now we are Indian standard also for our mixed design. But before going for Indian standard, what are the steps were involved in FNARC was first we used to take the air content by volume. Then we used to find out the coarse aggregate volume. Then we are going for a paste content. After having the paste content, now this paste content is depend upon the binder and the water. So we are finding out how much the binder or a cementitious material by weight should be there. After it, we are having a mineral admixture. If we are going for any replacement, what should be the percentage of it? And then we are finding out the water to binder ratio. Now, the difference in our language, we can say from FNARC to Indian standard, I will explain you later on. Then we are going to find out the volume of fine aggregate with respect to volume of mortar. Then we are having the SP dosage, that is a admixture dosage percentage with respect to the cementitious material. And finally, we are going to find out how much VMI we are going to introduce in our concrete. Now for Indian standard, the basic things which are changed is this only the flow and the classification of flow and the viscosity. Rest all you can say the mixed design process is almost the same. The only difference in our maximum size aggregate and the air content, which is mentioned in our table. As we go for IS 10262/2019, they have mentioned all the specification for our slump flow as well as for viscosity class. Now that is the difference is what I was used to say that if you see the after selection of admixture, that is a 6 step, the selection of powder content is there. So powder content and fine aggregate content. Now the powder content is nothing but the binder. That is a cement, that is a fine flash and GG base. These are the binders. Now, what actually powder content having a size of it should be less than 0.0125 mm. If we want to say it is a powder content, then the size of powder should be less than 0.0125 mm. And if it is above 125 mm, then it is considered as a fine aggregate only. Now, these are the specifications or we can say the limitations which is mentioned in FNARC, which has already taken in our mixed design also in our IS code. That's what should be the water to powder ratio, which is from 85 48 to 55. Then the coarse aggregate, it should be limited up to 270 to 360 liters per meter cube. The water content should not be less than 150 and should not exceed the 210 liters per meter cube. Powder content should be limited from 380 to 600 kg per meter cube. And the cement content, as per the European standard, it should be 350 to 450 kg per meter cube. These are the requirements or the limitations for the materials. But for the testing also, they have mentioned certain requirement. Now you can see there is a table I have mentioned where the instrument, which is the instrument we are going, or which test is going to represent what is the property of that self-compacting. Like if we want to find it out, the filling ability of our concrete, we can go for slump flow, we can go for V funnel, we can go for these two tests. If we want to find out the segregation of our concrete, we can use it, that is a V funnel. If we want to find out the passing ability, that is passing through all the reinforcement, through all the congested area, then we have to go for an instrument like L box, U box, or fill box. The limitations for, or we can say values for this test, as we can see, that's the for slump flow, it should be minimum 650 mm. These are, I'm showing it is for FNAR. If we see it is for Indian standard, it was a 550. I will show you it later on. It should be 550 to 800. For T50, that is a 2 seconds to 5 seconds. That is the initial time taken to empty the V funnel. It should be from 2 to 5 seconds. T0, that is 8 to 12. For T50, 5 minutes. After 5 minutes, this 12 seconds should not exceed then plus 3. That is 12 plus 3. That is 15 seconds. If it is exceeding 15 seconds, then it is having a segregation. So we have to change our mix design accordingly. For L box, the passing ability, that is a 0.8 to 1%. For U box, it should have minimum to 0 mm to 30 mm, the difference between the two heights of our concrete. When we put the concrete in one half of a concrete, it passed through the reinforcement below, and there is a change, there is a difference in between the level of concrete. That level should not be more than 30 mm, and filling ability should have at least minimum 20%, and of course it has to fill 100%. These are the self-compacting concrete. Now these are the basic things which most of the people or most of our seniors are having confusion or not having a fully concentrate, because of which there is a lot of differences. Why this 600 micron has been considered? Because if you can see, there is this is only the ISC which is not having an inter crossing limit of any of our percentage passing. (15 to 34). Zone 2 is showing from 35 to 59. Zone 3 is showing from 60 to 79. And from zone 4, it is 80 to 100. This zone is not having any value which is having a intercrossing. Other all the sieves are having an intercrossing. That's why this 600 micron sieve is most important in our concrete mix design. Now this table I'm showing because of a lot of people have asked me when we are selection of our water cement ratio with respect to our exposure condition, or selection of our minimum cement content with respect to our grade of concrete. So I just want to explain this table because a lot of people are having a confusion regarding what the value should be considered if we're going for our water cement ratio. Suppose we are as this table is mentioned, is for a durability purpose, it is not for strength purpose. So this durability purpose has to be considered, which is with respect to the exposure conditions. What is the exposure of our substrata? What is the exposure of superstrata? So according to it, the exposure condition has been divided in IS code, that is a mild, moderate, severe, very severe, and extreme. So to minimize the confusion, first we have to understand this table is only and only for the durability purpose. Likewise, suppose we are having a grade, something we are going for designing for M20 grade of concrete, which is might be the plain concrete, but we are designing that concrete in very extreme condition. Now the case is that we are designing for a plain concrete. For a minimum grade of concrete is M20. So what should be the maximum water cement ratio? So I have seen that a lot of people consider as a minimum, if we see the plain concrete table with a minimum grade of concrete, that is M20, they will consider as a 0.45 as a maximum water cement ratio. But as I said, this table is for the exposure. This table is for a durability purpose. So we have to first see that which is the exposure condition with the construction is going through. So if the exposure condition is very extreme, very severe, and we want to have a grade of concrete for M20, then only we can go for a maximum water cement ratio of 0.45. Otherwise, if we are having an extreme exposure, and even though the grade of concrete is said to be M20, it has to extend the grade of concrete to M25, and the maximum water cement ratio has to be considered as M40 only. Okay, understood. Same similarly, if we can understand regarding the reinforced concrete, suppose same thing if the grade is M20 or the grade is M30, and he's having a construction or the concrete which is going to place is in a exposure condition of very severe. So accordingly, a lot of people I have seen the considering the maximum water cement ratio as 0.45 as a maximum water cement ratio for a grade of minimum grade of concrete mentioned is M30. But it should be not the case, whereas we have to first consider as an exposure condition, then we can go for a minimum grade of concrete or a maximum water cement ratio. Thus, if we are going for a severe exposure condition, then it is okay to have an M30 grade of concrete with a maximum water cement ratio for 0.45. But if we are having a very severe condition, then we can't have an M30 grade of concrete. We have to design for M35 grade of concrete with the same water cement ratio as mentioned in that is 0.45, and for minimum cement content as a 340. This is a major change, or this is the main difference where a lot of people are not considering the exposure condition. They're just seeing the two tables and getting the value. So this is most important where I want to explain the exposure condition, that is 5 exposure condition: mild, moderate, severe, very severe, and extreme. They what are the exposure condition and how it is we can find it, or what kind of exposure condition we are going through, that has been mentioned in IS 456. I will show to it later on. These are the few basic that how we are changing our replacement of cementitious material or change in our water cement. I'm not going through this. Now these are the few mixed design which is now been changed or now has been revised. Okay, I will show you some slides where, as I mentioned, that I will explain you regarding the concrete mix design. I will share you the mixed design which I have been introduced with calculations. Okay, can you see the mixed design sheet?
Yes, sir.
As I mentioned earlier, that earlier we only used to feel the things which is mentioned in our mixed design, what are the values from where we have got it. But now they have mentioned that for each and every particular things you have to mention why it is so. Like if you see the row number 50, there's a maximum water content from a nominal maximum aggregate side of M20. It is 186, which has been in table. If I show you, there was a table. This was a table in our IS code that is for maximum aggregate size. If it is a M10, 10 mm, the water content should be 0.80208. For 20, it is 186, and for 48 is 168. This have to be mentioned over here that how it is 186 we have received, and it is for 50 mm. So we are providing this sheet, this mixed design sheet, this whole complete with a graph, combined graph, and how the calculation has been arrived. Earlier, we only used to, as this, we are not used to show. We are just giving the values, but now it has been mentioned that this value should be shown if it is required by the contractor or by the purchaser. So actually, this sheet I have been designing for. This is an auto sheet which is generated with respect to what is the grade if you want. If you want a grade from M40 to M95, I have designed, and the different type of concrete. That is, we want a early strength, self-compacting concrete, the dry lane concrete, my one, pile or PQC concrete, if it is required. That accordingly, I have designed this sheet. As I have mentioned, you have to show all these graphs, this combined graph also, and you have to mention how the values are arrived. Then this all these details should be mentioned to on paper before giving to them. This was regarding uh, grade of mixed design and what how we have to mention it. The specification or what is the clause with respect to the material we are going to use. That is what the material according to which IS standards confined it. And that automatically batch sheet starts. So this was regarding, as I mentioned you earlier, that what are the details we have to mention uh, for our mixed design is over here. I will show you one more which I have not actually explained. That is a pervious concrete. As we are going for a smart city, there is a requirement of a pervious concrete as well. So these are the design which we are following through our ACI standard. That is a 552 R, 552.R. We are going through this specification so that we can have a mixed design for our pervious concrete. As you can see over here, it's mentioned what are the limitations and what are the circumstances where we have to use our mixed aggregate to cement ratio or our cementitious material. According to the ACI standard, it is mentioned that the cementitious should be not less than 270 kg. It should range from 270 to 415 kg itself, and the aggregate should have around 1190 to 1480. The aggregate which I am mentioning is a coarse aggregate. Aggregate uh, water to cementitious material is mentioned as not should be less than 0.27 and should not more than 0.34. And aggregate to cement ratio should be 4 or 4.5 is to 1 ratio. Well, fine aggregate, if we are going for a fine aggregate, it should not have more than 1.1 ratio for fine aggregate. This I have only mentioned in very short regarding the mixed design, which I will share it to you. As I was mentioning, the steps which are involved in our mixed design, I will go through it. Like we have to first mention that what grade of concrete we are going for, because it is a requirement as per the uh, purchaser, that which grade of concrete we required. As suppose we are going for M95 grade of concrete, and for early strength, and we are going for M10 minimum aggregate size is M10 for a severe condition with a flow ratio of around 700, 600 to 650. Now, this all the tables has been mentioned over here. You can see this is the graph. And according to the grade of concrete, the standard deviation will be calculated automatically, and the target strength as well. As we have mentioned over here, you can see there is a change in our concrete grade. There's a 1.65 which is mentioned. There's a 1.65. A lot of people are considering 1.65 for our standard deviation. Just to understand why we are going for 1.65 is, it is said that if the failure ratio of our compressive strength, if it's a failure ratio is 1 in 20, that is a ratio of 5%. That's why we consider mostly 95% of our as a positive result and 5% as a failure. In that circumstances, we are considering as a 1.65 as a standard deviation. This will change. This will change if we are considering more or less failure. If suppose if we consider that as a 1 in 100, that is only the 1% failure in concrete, then the value will change to 2.77. Now understand this. This 1.65, again I will explain. The 1.65 is a ratio of failure of concrete is a 5%. That is 1 in 20. That's why it is 1.65. If we going to change this acceptable ratio, that is a failure ratio, we are considering as a this failure ratio as only 1%, the value will raise to 2.77. This is as per the standard deviation, or we can say the bell curve, which is designed during our finding out the failure of the acceptable failure percentage. The bell curve is designed, and then we can go for 1.65 for a 1 in 20. Now you can see, as I mentioned in our mixed design, first we have to find put all the details, what are the requirement of our concrete. Then when we are finding out, first we have to go for air content, which automatically already calculated. Then accordingly, we are finding out the water content, which is, as you can see, the water content from earlier it was for M20, now it is MS20. So that this has been changed to MS10. It is 208 kg for 50 mm slump. Now it will change accordingly. If we see, suppose our the water content is changed to 18% with respect to our flow. Now, as I mentioned, that this 208 is for 50 kg. For 600, it will change for 18%, which I have mentioned over here in shade. Yeah, this one. For 3% is mentioned 3% of 75 mm for 3%. As we are increasing the sum from 25 plus, then for each 25, we are increasing the percentage by 3%. For 75, it will be 3. For 100, it is 6, 9, 12, 15. Then as we go beyond 200 mm, it is not slum, it is flow. So we are considering as the flow. So considering as a percentage increase will be the same. We are considering as a 18% only. And as we are going for admixture, change in water content. Then the thing which I want to tell you over here is we have to show all the details for why this value has been arrived, from where it has been arrived. This should be mentioned, and not only this sheet is also should be provided to our customer, whoever is getting the concrete mix design. Okay, so final to conclude is that we are having a lot of type of concrete, which mix design is most important part, because its basic change in the properties will ultimately result in final amount or final specification of concrete. Thus, the basics should be understand first what are the material we are going for, what are the kind of material we are going for, what is the limitations which is involved in for mixed design, what are the maximum or minimum limits of our material, which is specified by our lot of IS codes or lot of standards. That is most important part. So this concrete type is from self-healing concrete, for pervious concrete. As I have mentioned, I have gone through the self-healing, as I can show you, but now actually having some issues regarding the Excel sheet. So a lot of concrete mixed design can now we will go through it. The clause said, I mean, we will go through later on purpose. Yeah, the clause is this one. As a guarantor of a quality of concrete used in construction, earlier it was mentioned that is as a guarantor of quality of concrete used in construction, the contractor shall carry out the mixed design and mixed design, not to the method of design. shall be approved by the employer within the limit of parameters and other stipulation laid down by this standard. But now it has been said that within the limitation of parameters and other stipulation laid down by this standard, if so desired, the employer shall be provided with a supporting data, including graph showing strength versus water cement ratio for the range of proportions, concrete trials proportion, detail to be sustained, the cement content, fine coarse aggregate, water, mineral admixture, chemical admixture, etc. So why I have shown all the standards of the new amendment? Because a lot of people ask that if you are going for M20, why you are going for a higher water cement ratio or a minimum water cement ratio? We can go through for a M20, we can go for 0.5 water cement ratio, but we have to consider the amendment which is mentioned, because the structure is most important part. We have to show them this thing has been mentioned in IS code and we have to change according to it, and we have to arrange the strength of concrete or arrange the grade of concrete according to the exposure conditions. So these are the questions, these are the things which I think most important part before going for a mixed design, which are mostly neglected. Have this all information and they will designing according to it, and we will have a safe and very good quality of concrete. So thank you for all. Any questions I will like to answer it.
Hello, sir.
Hello.
Hello.
Yeah.
Now, when we take that characteristic compression strength plus risk factor into standard deviation, and that this new code 2019 says that either you take that or FCK plus X. So, but always when we say X,
Hello.
always it works out to be less, and always you have to stick to that 1.6.2 standard deviation only. So why?
Right.
I mean, why that X is brought in then? Why they don't go for X then in that case?
Yeah, actually, you can go through it if we are going for a X value, which is mentioned that there is a formula given in IS code, and you can use that X value if you are having 100% sure about the values which you are getting. Why they are saying you should go for 1.65? Because there are a lot of errors at our side, and we are getting that values which is based on our site, right? This X value is according to the side values which you are getting it, and it at least it should have a minimum 30 values, because we are going for the whole month periodic table. So if you are considering this X value, then you should have a minimum 30 value with all the you can say safety or precautions like this. Why 1.65 has been arrived in a control condition, and this X value we are going to calculate as per our site condition. That's why you can consider it as requirement. I'm sure that will go on rise. It will be on a higher side. So better to have at a 1.65 as per the IS, because 5% failure is acceptable as per IS standard. But if you think that you need to have a more quality, better quality, then you should go through your X value from calculations.
Thank you, sir.
Any more questions from the participant side? Okay, sir, so we will wind up the session. I invite Saili ma'am to give the vote of thanks.
Bharati Vidyapit Institute of Technology, I take this opportunity to extend our heartfelt gratitude to Mr. Shrikant Varpe sir for his insightful and engaging session. Your vast experience in the construction sector and practical knowledge you shared today have truly enriched this faculty development program. With that, we conclude today's session. Thank you once again, sir. Thank you, sir.
Thank you so much, sir.
Thank you.
We will meet again tomorrow's session at 6 p.m.
Thank you to all the participants. Please do join tomorrow at 6 p.m.